Here we are. It's Wednesday, May 20th. Today we're going to talk about how to calculate the volume and the surface area of a sphere, and then we will work through some practice problems and applications of these two ideas. Please keep in mind that the end of the marking period is coming soon. Next week is our last week of new instruction. After next week, it's all about catching up. Now, if you are caught up on assignments, including the one that will be posted on Wednesday next week, then you are finished. You are done at the end of May. But if you are not caught up at the end of next week, then you will be using time in June to finish your work for this class or any others that you are still completing assignments for. Please don't hesitate to let me know if you have any questions about that. Let's get started with today's lesson. The formulas for the surface area and volume of a sphere are shown. A sphere is a 3D version of a circle. So just like a circle has a radius, our sphere has a radius as well. From the center of the sphere out to the edge is the radius. So to calculate the surface area, we're going to take 4 times pi times the radius squared. If our radius is 6 feet, that means our surface area is equal to 4 times pi times 6 squared. When we start to simplify this, we can write our answer as an exact answer, which would be 144 pi, or we can write this as an approximate answer by using our calculator to multiply 144 times pi using the pi button. Doing so and rounding to the hundredths place gives us an approximate surface area of 452.39 feet squared. Remember, since surface area is an area calculation, our dimensions are squared. For volume, we're going to take 4/3 times pi times our radius of 6 cubed. If we cube 6, we get 216. So our volume is equal to 4/3 times pi times 216. To simplify this further with the fraction, remember that multiplication is commutative. This means we can switch up the order of these 3 terms. And as a little side here, what we're doing is we are going to take 4/3 and multiply it by 216 for our exact answer. Doing so gives us an exact volume of 288 pi. And again, if we want the approximate answer, we take 288, multiply it by pi using the pi button on our calculator, and rounding to the hundredths place gives us an approximate volume of 904.78 feet cubed. Our dimensions for volume are always cubed. Let's apply these ideas. So in this first problem, Mrs. Voisinette loves ice cream. I really do, especially chocolate peanut butter. Anything that's chocolate peanut butter is absolutely amazing in my book. One sunny day, she decides to eat an ice cream cone that has the dimensions shown below. If the entire cone is filled with ice cream and the shape of the ice cream above the cone is the top half of a sphere, how much ice cream am I eating? Well, if we're talking about how much stuff is inside that sphere shape for the ice cream and how much is inside of the cone, we're talking about a volume measurement. Sometimes when we calculate the volume, it's of a single shape. Other times it's of 2 shapes put together. So we are calculating the volume of half of a sphere or a hemisphere and the volume of a cone. My hemisphere has a radius of 3 centimeters. If that was a full sphere, the volume would equal 4/3 times pi times my radius, which is 3 cubed. But I only need half of it. So I'm also going to multiply all of that by 1/2. The volume of my cone is found by taking 1/3 times pi times the radius squared times the height of my cone, which is 6. And now I need to simplify. So the way we're going to do this is we're going to do this in 2 parts. We're going to simplify all of this for volume of the sphere first, and all of this for volume of the cone second. Then we will worry about combining them together. As I'm simplifying things, I'm going to change the order of the terms to help us with multiplication. So my volume is equal to 1/2 times 4/3 times 3 cubed, which is 27, and I'm going to put that over 1 so it looks like a fraction, times pi, plus 1/3 times 3 squared, which is 9, times 6 times pi. Multiplying 1/2 times 4/3 times 27 gives us 18, and then we're multiplying that by pi, plus 1/3 times 9 times 6 also gives us 18, and then we're multiplying by pi. Combining these together tells me that the total area is 36 pi centimeters cubed. And I'm realizing just a few seconds ago, I said that gives us the total area, and what I meant was it gives us the total volume. So this is our exact volume, and again, if I want the approximate volume, I'm just going to take 36, multiply it by pi using the pi button on my calculator, rounding to 2 decimal places, or the hundredths place gives us 113.1, actually because of the 0.09, we'll round up to 1, centimeters cubed. So that means I am eating 113.1 centimeters cubed of chocolate peanut butter ice cream. Yum. Let's talk a little bit about the connection between spheres of different sizes and their volume. All spheres are similar to each other. They just have different lengths for their radius. So if we have 2 spheres where one has a radius of 5 and the other has a radius of 7.5, because they're similar, we can figure out what the scale factor is between those 2 spheres. And the scale factor is based on the change from one radius to the next. If I want to know, for example, how to go from the small sphere to the large sphere, I'm going to take a look at what happens when I take 7.5 and divide it by 5, which is 1.5. So to go from small to large, my scale factor is 1.5 because 5 times 1.5 gives me 7.5. So we can figure out a scale factor for 2 spheres just like we would figure out a scale factor for two-dimensional figures, or maybe 2 cubes or 2 rectangular prisms, all right? So the next question says, how much more volume does the larger sphere hold? Well, we could go ahead and calculate the volume of sphere number 1, and we could go ahead and calculate the volume of sphere number 2 and compare them to each other. But we can also do this based on scale factor. Remember that volume is 3-dimensional. And so this means that scale factor affects the volume to the 3rd power. A couple chapters ago, when we were talking about how scale factor affects perimeter and area, we said that perimeter was a 1-dimensional measurement. So that meant that scale factor affected perimeter by multiplication 1 time or to the 1st power. Area is a 2-dimensional measurement, and so scale factor affects the area twice, so in other words, to the second power. Volume is three-dimensional, and so scale factor affects volume to the third power. So that means if I take 1.5 and cube it, I will know how many times the volume of the larger sphere is greater than the volume of the smaller sphere. Cubing 1.5 gives us 3.375. So that means the larger sphere has a volume that is 3.375 times greater than the volume of the smaller sphere. This same idea applies to surface area as well, but remember that surface area is an area calculation, and so we only need to raise that scale factor to the second power to see how it affects the area moving from the smaller sphere to the larger sphere. If we were to take 1.5 and square it, we would get 2.25. That means the larger sphere has a surface area that is 2.25 times the volume of the smaller sphere. Our final problem is an application problem where we have a glass ornament being packaged in a square box. And there's some empty space surrounding the ornament that's going to be filled with packing material for shipping. So if the ornament has a diameter of 4 inches, what is its volume? Notice they gave us the measurement of the diameter, not the radius. So we have to be careful with that because our formula for volume uses the radius, not the diameter. If the diameter is 4, the radius is 2 inches. So to calculate the volume of the ornament, we need 4/3 times pi times the radius, which is 2, cubed. When simplifying, I'm going to rewrite so that my fraction and my radius squared are next to each other. I've got 4/3 times 4 times pi, which gives me 16/3 pi for the exact volume of my sphere. The approximate answer, rounded to 2 decimal places or the hundredths place, is 16.76 cubic inches. Now, part B says the box is a cube with a side length of 5 inches. What is the volume of a box? Well, for the volume of a cube, it's just the side length cubed. So that's 5 cubed, or 125 cubic inches. What is the volume of the packing material needed to fill the empty space? Well, this becomes a subtraction problem. We have our entire cube, and the ornament takes up some of that space, so we can't consider that space. But when we take away the space that the ornament takes up from the entire space inside of the cube, we'll be left with the space for our packing material. This means we just need to take the volume of the box, the 125, and subtract from it the volume of the sphere, the glass ornament, which was 16.76, and that will give us the amount of space left for our packing material. We will have 108.24 cubic inches left for packing material. That's it for today's lesson. We are almost to the end. Keep that focus, Bulldogs. So now you're going to go complete the lesson check that's posted in this lesson tab along with the video that you just went through, and get that turned into me. Your assignment for this week is just going to be to make sure that you've completed the lesson check from Monday and today's lesson check. Next week, we'll have a little something for you to do on Wednesday that will be due on Friday, and that wraps up our work for this year in geometry. So again, Make sure you're caught up on your work so that at the end of next week, you can just relax and be done. If you're not done by the end of next week, know that you have some time in June to get caught up, but try to get your work in as soon as possible so that you can enjoy your summer. I miss you guys. I hope you're doing well. Stay safe, and please let me know if you have any questions.